Hey there, guys. We are starting Chapter 4, Section 4 here for Math 8. We're going on to our next exponent rule. You might remember that the last section we talked about multiplying terms together and what happens to the exponents when you multiply terms together. Like if you multiply 2x squared times 3x to the fifth, you get 6x, and you add the exponents, and it would be 6x to the seventh. Remember, you multiply the coefficients, but you add the exponents. Well, we're going to look today at what happens when you have a power to another power. That's like an exponent raised to another exponent. We're going to look at what happens that. So first, I have an example of something with an exponent raised to another exponent. And we're going to see what happens here. So we're going to start this problem by writing it out in expanded form using just the 3. So what is the 3 over here telling me to do? It's telling me to multiply the x squared times itself 3 times. So it would look like that, right? And then we are going to do more expanding. This time we're going to use each 2. So like, what does this 2 really mean? It means x times x. Let's make those real big. And then what does this 2 really mean? Well, that one also means x times x times, and how about this 2? That one also means x times x. So when I expand this thing out completely, how many x's do I actually have? Well, obviously I have 1, 2, 3, 4, 5, 6, all being multiplied together, which makes this thing equal x to the 6th. Now, what we'd like to do is not have to expand it, right? It is easy to figure out the answer when you expand it all using the exponents. But what we'd like to do is go straight from here down to here. And if you learn the rule with the exponents, you can do that. And here is the rule. When you have a power raised to another power, when you have an exponent raised to another exponent, then what you could do is just multiply the exponents together. You can see up top there where I could have just multiplied the 2 and the 3 together, and it would have given me the 6. And that would have saved me having to go through all this work, right? So we're going to do a couple examples, right? You might try to get the examples before I do. This first one is x to the 5th to the 2nd. You know, I could write it out. I don't want to, but I could. This would be x to the 5th times x to the 5th, which would be x times 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 x. Mercy. And that is 10 x's multiplied together, giving you x to the 10th. Wouldn't it be easier just to learn the rule that when you have an exponent raised to another exponent, you multiply them together, and that's where you get x to the 10th. The second one here, I have 3 squared to the 4th power. So this time I'm not going to write it all out. That is just going to equal 3 to the 2 times 4. An exponent to an exponent, you just multiply them together, giving you 3 to the 8th. And last up, I think you've probably got this figured out by now. This would be n to the 4 times 3, or n to the 12th power. It's really a pretty simple rule, right? When you have an exponent raised to another exponent, you just multiply them together. So that brings us to a similar situation where we will use that rule. and that is the power of a product. Now, a product is just stuff multiplied together. I don't know if you remember that, probably from 5th or 6th grade, you learned in a multiplication problem, the answer is called the product. And what we're going to do is we're going to take a bunch of stuff multiplied together and put an exponent on the whole thing. That's why it's called the power of a product. It's a bunch of stuff multiplied together with a power on it then, or an exponent on it. And I want to give you a couple reminders. So first, when you have an exponent on a product, a bunch of stuff multiplied together, you apply the exponent to each individual thing in the product. Now you got to remember something here. This is the biggest mistake I see. When you raise a number to an exponent, that would be like if you had 2 to the 3rd power. That equals 2 times 2 times 2, right? You multiply the number by itself. But as we've just learned, when you multiply or when you raise an exponent to an exponent, like you have x squared to the 3rd power. So you have an exponent to an exponent. It is not the same as this. These are not treated the same, right? A number to an exponent is different than an exponent to an exponent. When you have an exponent to an exponent, you multiply the exponents together. This would be x to the 6th. Whereas up here, it's 2 times 2 times 2, which is 8. All right, we want to remember that as we do these examples. So I'm going to do the first example and show you how I think you should do it. And then I think you should try the next 3 on your own, pause the video and try them, and then turn it back on and see if you got it. So in this first example, what I would do is I would apply this 4 to each thing. And I would write that out. So this would be 2 to the 4th power, x to the 5th to the 4th power, y squared to the 4th power. I really like writing out that line. And then I see what each one equals. So 2 to the 4th power, that is 2 times 2 times 2 times 2. That is 16. X to the 5th to the 4th power, this time I have an exponent to an exponent, so I multiply them together and get x to the 20th. And again here I have an exponent to an exponent, so I multiply them together and get 8, y to the 8th. Notice, you guys, that, notice that these two things did not get handled the same way, right? This one was a number to an exponent, and this one was an exponent to an exponent. So they turned out differently. All right, I think you should try the next 3 and then start the video again and see if you got them, but I'm going to do them. So here we go. All right, so in this first one, I should apply the 3. Hopefully you did this already. 4 to the 3rd, x to the 3rd, y to the 6th to the 3rd. And then let's see what all that equals. Well, the 4 to the 3rd would be 4 times 4 times 4. That is 64. Perhaps you have to use your calculator for that. The x to the 3rd would still be x to the 3rd, but the y, since it has a power to a power, would be y to the 18th when you multiply the 6 times the 3. In the next one, I would apply the 2 to each thing. -3 to the 2nd, w to the 2nd, x to the 4th to the 2nd, y to the 3rd to the 2nd. And then I would evaluate each of these. -3 to the second is -3 times -3, which is +9. The w to the second would still be w to the second. Here I have a power to a power, so I multiply them and get x to the 8th. And here again, I have an exponent to another exponent, so I multiply them and get y to the 6th. And this last one, I would probably PEMDAS it. So I would do what's in parentheses first and get 10 to the second power. And 10 to the second power is 10 times 10, which is 100. All right, I think I have one more thing, and we're about done. We are going to do 2 of these examples. We are not going to do the other 2 examples if I put them on there. I did. We're not going to do all 4. We're just going to do the first 2. Can you get 2 out of 2? It's a little tricky here. But look, I want to point this out. So you want to make sure that when you do these operations, you do them in the correct order of PEMDAS. If you have more than one operation to do, make sure you do parentheses first and then exponents and so on, right? So in example A here, look, I know this looks difficult, but this problem is really no more difficult than if you had 2 times 3 plus, I don't know, 5 times 2. I think all of you guys could do that problem mentally, right? You would multiply this, you would multiply this, and then you would add 6 and 10. Well, this one is no different. You're going to multiply this and multiply this, and then you're going to add the results. You just have to use your multiplying skills with exponents. So remember, when you're multiplying things together, you multiply the coefficients, but you add the exponents. This would be 8x to the 8th. This one, if I multiply the coefficients, I get 15. And if I add the exponents, don't forget about the hidden 1, I get x to the 8th. Now, these 2 things can be added together. They can be added together because they are like terms. Remember what like terms are. Like terms are terms that have the same variable with the same exponent. So if you have 2 things that are like terms, you can add or subtract them. In this case, I can add them, and when I add them, I keep, that's not what I wanted, I keep the x to the 8th. When you add terms together, the variable and exponent do not change. And you just add the coefficients. 8 of these things plus 15 of these things gives me 23 of these things, these x to the 8ths. And we're done with that one. A reminder on how to add like terms together. Let's look at letter B and we'll call it a day. So in letter B, I need to multiply this first. So I'm going to get 3y squared plus something. And when you multiply these, you multiply the coefficients. That would be 10. And there's just a y to the 3rd. So I have 3y squared plus 10y to the 3rd. Now, what do I get when I add those together? Well, here's the thing, you guys. I hope you caught this. Those are not like terms. They do not have the same variable with the same exponent. And if they are not like terms, you cannot add them together. This actually is your final answer. There's nothing you can do from there. All right? You got the homework. Good luck. I will see you guys tomorrow.